Section 7.1, confidence intervals with a known sigma. Here's another example of where we want to find a confidence interval. This time we need to identify that best point of estimate of the mean is. They do give you the mean of 54 days. The sigma is identified as 6, the number in the sample 50, and a confidence interval is 95%. Knowing that, then you can find your z-value of 1.96. Using all of that information, substitute the values into your formula. Working it through, getting your answer, we're going to use 52 since our mean was at 54, rounded to the nearest whole number. How to summarize this would be, one can say that with 95% confidence that the interval between 52 and 56 days contains the population mean based on that sample of 50 automobiles. My example comes from page 379. We're looking at a sample of 50 retired men. They told the statistician that the average number of jobs they've held approximately 7.2, the standard deviation of 2.1. We want to first identify the best point estimate of that population mean, and then with 95% confidence tell where that population mean would go. With the information that's given, I can identify that the best point of estimate of that population mean is actually going to be the 7.2. That the sample mean. All right. Now this next part is we want to know 95% confidence that the population mean will fall in between the 95%. That gives me the idea that my z sub alpha divided by 2 is going to be 1.96. Now, substituting in my formula, I take my mean minus that z-value divided by sigma divided by the square root of the population. That's going to be the smaller size. Then to get the upper part, we're going to add that margin of error. Square root of 50 to finish it out. Okay, now that I've got that all information written down, I can then type this into the calculator. Again, you can type it all in as one, or you can type it into as piece by piece. I end up getting an answer of 6 6/10. I know I'm rounding to the tenths because that's what my mean population was. And then I need to do the other part, and that is 7 8/10. What this says is that with 95% confidence, I can say that the population mean will fall between 6 6/10 jobs and 7 8/10. Some of you may be wondering, is there a way to get this information on the calculator? And the answer to that is yes. Here are the steps. You're first going to go to stats, then you'll go to tests, and then z interval. Now there are two ways that you can get those confidence intervals, either by giving the statistics or having a list of data. If you have the known the standard deviation and the mean, you're going to use the statistics option. If you're going to be putting your data into a list, then you're going to use the data option. For the previous example, we could go ahead and put in our information. Again, that is statistics over to test, and we want the z interval, which you can see is number 7. Here it gives you that list of what we're looking for. Since I know that my standard deviation is given to me, I am going to use the data option. And my standard deviation for this particular case is 2.1. Then I am going to go to my I have to back this up a little bit because if you recall, we're actually given the statistics. So I need to select the statistics one. Okay. Now I'm ready to do that 2.1. Then my X bar was 7.2. And then my number in my sample was 50 men. Confidence level 95%. Leave it as a decimal. Go ahead and hit calculate. The values on your screen then would become that 6.6. Notice how in the previous example, we just rounded to the nearest tenth. Here, they're giving you a little bit more accurate answer. But that's how you would use the calculator to get those intervals. Here's an example when they give you a set of raw data and you need to figure out the interval of that data with just that information. I'm going to give you a few moments to read through example number 14. Once you're done reading through the example, I would encourage you to enter in your list of data into your calculator. Then go ahead and start up the video again so that we can proceed. Now I've entered all the GPAs into list 1. Go to Stat, Calculate, and 1 bar Stats. This is going to then give me the mean of that sample, 2.8. Now that I have all of the pieces, I can go ahead and enter in my formula. 2.8 minus that Z value for 99% confidence is 2.58. So I know that part. Then do the sigma, population standard deviation, divided by my sample size. You can also get the sample size from our calculator, and that was 36, but you can also count up how many were in the sample. 36. Less than the mean of the population. Now we're going to do adding that margin of error, 2.58, 0.62. For those of you who recognize that the square root of 36 is actually 6, you can put that in there. Getting that put into our calculator and getting an answer of 2.55, and then we've got an answer of 3.08. I know I'm rounding to 2 decimal places because of my raw data was actually to 1 decimal place, so you could round it to 2.6. Oh, we always go one higher, one more than the raw data. So since the raw data was to the tenths, I'm going to go to the hundredths. Got to remind myself of those rounding rules too. Now you can also get the calculator to figure out that confidence interval. You've already got that list put into the calculator. Go to Stats, over to Test. We're doing our Z interval, number 7. Now this time the data is going to be our selection. The sigma was 0.26. It's coming from list 1. Frequency, leave as 1. Our confidence interval was 99%, so I'm going to change that to 0.99 and then hit calculate. And there matches the numbers that we had originally gotten when we used the actual formula. Notice how it's giving you the mean of the sample as well as the standard deviation of the sample. Here is the number in the sample. Kind of nice information for you to gather. But what we're really looking for is that interval of the population mean. Please take some time to read through this information regarding the computers versus calculator usage. Pause the video, you can read through it, and then go ahead and start back up again. In stats, we may need to know how many we need to have for our sample size to get a certain degree of confidence. Here is the formula that we can use to find that sample size. One of the things to consider is how large a sample is necessary to make an accurate estimate. This depends on three things: the margin of error, the population standard deviation, and the degree of confidence. My example comes from question number 23. How large of a sample to be 90% confident of the population mean is within 10 minutes of the sample mean, knowing that the standard deviation is 42 minutes. Using the formula, now we can actually figure out how large that sample size needs to be. 1.65 is our z value for that 90% confidence, times 42, our standard deviation, divided by that margin of error. We wanted to be within 10 minutes of our mean, so that e value represents 10. Then we're going to take that answer and square it. You want to type that into the calculator, you can do so. You're going to get an answer of 48 2/2. Because we're talking about a sample size, we do need to round up to the next whole value. That gives us 49. This tells me now that the sample size I need to get that 90% confidence level is 49. This concludes section 7.1. Please go to your assignment and start working on the problems. If you have any problems or questions, please let me know right away. Thank you very much.